Alright, welcome back. Here's our second video in section 3b, polynomial functions. We're going to talk about what we call the end behavior of polynomials. Alright, an end behavior is simply a way to describe where the arrows point. Okay, and we always talk about end behavior from left to right. So as we travel along the x-axis, left to right, what are the arrows doing? All right, so let's just start simple with one of our lines. 2x minus 3, we already graphed this one in the last video. All right, so if we look at the arrows, we would say that this graph left to right, traveling up the line, starts down low and ends up high. Okay, so on the left-hand side, it starts down at negative infinity, ends up high at positive infinity. Our second line, that was negative 1/3 x plus 1. That one, again, left to right, is going to start up high on your graph paper. On the right, it's going to end low. Okay, my quadratics, we have that upward opening parabola, both on the left-hand side and on the right-hand side, it's pointing upwards. So we're going to say that it starts high and ends high. And then the downward opening parabola, we'd say it starts low and ends low. Okay, and all four of those things, those different combinations of starting low and high, all of those were determined by looking at the degree. Okay, these two had a degree 1, and then the quadratics were degree 2. That sort of told us where what the shape was going to look like, and then we decided by looking at the leading coefficient whether it was going to be a line rising left to right or a parabola opening upwards or downwards. Okay, so likewise when we move on to polynomials, we can tell what the end behavior is going to be by looking at the degree and the leading coefficient. All right, so I'm going to head back over to Desmos. And let's see if we can get out of here. Come on. All right. Let me get myself a blank graph here. All right. So I just want to see, like, if the degree is 3, what does the end behavior look like? Well, we know what x cubed looks like. All right, that's going to start low and end high. And then notice that it doesn't matter if I add on an x squared, if I subtract the x squared, if I mix and match with, oops, not that. How about we put in minus 7x? Okay, I can add on an x. Again, it doesn't matter if it's plus x or minus x. Doesn't matter if I add 2 at the end. Okay, the lower powered terms don't really change the end behavior. When it's x cubed, it's going to start low and end high, just like the plain x cubed graph. Okay, and if I change that to a negative out front, that definitely changes the shape of the graph, right? But that kind of doesn't matter what I do over here. It changes the wiggling to put those different lower powered terms in there. All right, but it just really matters what the degree is, that it's a cubic, and whether the lead coefficient is positive or negative. All right, so let's get one in here that's nice and wavy. There we go. Notice that the end behavior starting low and ending high is really the same as those lines. Like when I put in the 2x minus 3, all right, it doesn't look very steep because, again, my y-axis is kind of going from negative 40 to 40. Okay, but that starting low and ending high thing, it has to do with the fact of the positive leading coefficient and also this odd degree, right? That x is really x to the first power, all right? And again, if I change my leading coefficient to a negative, okay, as far as where the arrows are pointing, they're kind of doing the same thing. And this all has to do with the fact that they have an odd degree and whether the leading coefficient is positive or negative. All right, so likewise, when I start to go look at an x to the 4th graph, let's play around with this. Well, x to the 4th by itself kind of looks like a parabola with a flat bottom. All right, so again, it's behaving just like x squared as far as its arrows are concerned, right? Starting up high and ending up high. All right, and again, it doesn't matter. It's 5x squared. I'm just kind of throwing stuff on. Oops, not 5 squared. How about 5x squared? And then minus 10x, all right, and then minus 6. Okay, doesn't matter what I put on there. And again, I can change these pluses, minuses. It changes all the wiggling, but it doesn't change that the arrows are both going up. The only thing that's going to change the arrows going up is the same thing that I could do for x squared, right? X squared, if I want the arrows to go down, I would have to put a negative leading coefficient on it. Okay, and the interplay of the positives and negatives on the x to the fourth and the x cubed, that's what's changing the shape in the middle. But what has to do with the arrows on the end is whether it's an even degreed polynomial and whether the lead coefficient is positive or negative. All right, so we're going to kind of try to summarize that over here in a chart. Okay. All right, so you can tell where the arrows are going to go based on whether it's an odd degree, an even degree, and whether the positive leading coefficient is positive or negative. And you don't really need to memorize this or try to work too hard at it. You already know everything you need to know. Odd degree polynomials are going to behave like lines because lines are odd degree polynomials, right? Remember, a line is an mx plus b, x to the first is an odd power. So x to the first, x cubed, x to the fifth, x to the 75th is going to behave, as far as the arrows are concerned, just like a line. Okay, it's going to rise left to right if it's got a positive leading coefficient and fall left to right if it's got a negative leading coefficient. Starts high and ends low. And then the even degree polynomials, the arrows, the end behavior is going to act like our quadratic. For a positive leading coefficient, they'll point up. For a negative leading coefficient, they'll point low. All right, so we can tell where the arrows are going to go just by looking at the degree and the leading coefficient. We can't necessarily tell about all that wiggling around in the middle, the roller coaster part of the graph, but we can tell where the arrows are going to go on the left and the right. All right, so let's look at those functions that we already listed the degree and leading coefficient for and just predict the end behavior. All right, so remember this one, we found that the degree was equal to 3. This is the same function we did in the last video, and that the lead coefficient was equal to 2. And again, I don't really care so much when we're talking about end behavior that the degree is 3. I mostly care that this is an odd degreed polynomial. And then the leading coefficient, it's not so important that it's a 2, but that it's a positive number. All right, so this is going to behave at the arrows, the end behavior, just like any odd degreed function, like a line with a positive coefficient. It's going to rise left to right. Now this polynomial is not a line. It's going to start down low with its arrow. Somewhere in the middle, it's going to do its roller coaster business. We don't know. It's going to wiggle around. And then at the end, it's going to end high. Okay, so all this is telling us is about the end behavior. It's going to start low and end high. All right, so then this polynomial, we decided that its degree was 4. And again, I really only care for end behavior, that that's even, and that its lead coefficient was -6. I care that that's negative. All right, so this function is going to behave like an even degreed function, like a quadratic. An x squared is an even degreed polynomial. And when an even degreed polynomial has a negative coefficient, it's going to behave like -x squared, where it points down. Okay, so, and again, it's not going to look like a parabola, this graph, but it is going to start low. It's going to wiggle around somewhat in the middle and then end low. All right, so let's see. So this one up here, we should have said it's going to start low, and then it's going to end high. And this one, we're going to predict that it's going to start low and end low. All right, so let's see if we're right. We're going to go over to Desmos, and we're going to graph 2x cubed minus x squared plus 5x minus 7, and we'll see if our prediction about this one and the next one was correct. Okay, so let's get out of here. And go over to Desmos. I'm going to clear out this one. All right. What was our first one? It was 2x cubed minus x squared plus 5x minus 7. All right. That one didn't wiggle around hardly at all. It's even a little steeper than x. Didn't even flatten out as much as x cubed. All right, but we were right. We predicted that it was going to start low and end high, just like a line with a positive slope. All right, and then we also had x squared minus 6x to the 4th plus 1. All right, and yeah, so this one didn't wiggle around a whole lot. It kind of looks like it flattens out a little bit there in the middle. All right, but again, we were predicting end behavior, which is the arrows starts low and ends low, and we were right about that. Okay, so that is end behavior. So now we can look at the polynomial and tell where the arrows are going to go at the end. The middle, we are going to figure out all that wiggling in the middle by looking at the x-intercepts or the zeros, and we're going to take care of that in the next video.